Hi grade 10s and welcome to this video. In this video, we will be working on the Mathematics Paper 1 for June 2024. And this is specifically from the Gauteng province. This paper counts for 50 marks and the time allocated is 1 hour. And looking at the instructions, just remember that there are a total of 5 questions in this exam paper and all answers should be rounded off to 2 decimal places unless stated otherwise. And also, the diagrams are not necessarily drawn to scale. Okay, with that being said, let's get into this video. Question 1 says, if x is an element of 0, 1, 2, 3, and 4, okay, so x is equal to all those values, write down the value of x such that k is, and we first have to find if k is undefined. Okay, so for an expression or for a value to be undefined, the denominator should be equal to 0. So whatever makes this denominator equal to 0 is what we're going to work with. It's square rooted, but of course, if you square root 0, you still get 0. So as long as 4 minus x is equal to 0, then this expression, okay, the value of k will be undefined. So we can go ahead and just transpose the x and take it over. So we all know that this should simply be equal to 4. So if x is equal to 4, then k is undefined. And that is our answer. Moving on to the next question. Question 1.2, we need to find the values of x for which k is going to be rational. Okay, so what will make k a rational number? As long as it doesn't end up with a surd. So it says square root, but as long as we can square root the numerator and the denominator, then it won't be a surd. Now in this case, you can see the numerator is a square number. And so 4 minus a specific number should just give us a square number and then it won't end up being a surd. So something you can do is take your x values and substitute just to test which would give you a rational number. So if we try 0, okay, we have 4 minus 0, which is 4. And so you have the square root of 9, which is 3, over the square root of 4, which is 2. This is a rational number. So k here would be rational, meaning this happens when x is equal to 0. Let's also go ahead and try for other values because this doesn't work like undefined. Undefined, the denominator should just be equal to 0 and then that is it. So with this, let's see if we try 1, what happens. 4 minus 1 is 3, but you know that you can't really say square root of 3 and then get an integer value. This will remain a surd. And so your answer, which would be 3 over root 3, this is still irrational. Okay, so that doesn't work. Let's try 2. Okay, 4 minus 2 is 2, but then you see that that denominator is going to say square root 2. The numerator is fine. Square root of 9 is 3. Okay, but then because the denominator is a surd, an irrational number, it's not going to work. Let's try 3. So if you try 3, you see that 4 minus 3 is 1. Square root of 1 is 1. So 3 over 1 is 3, which is a rational number. So that works. So, or x is equal to 3. And then, of course, we know that 4 doesn't work because 4 makes it undefined. And that is our answer. Moving on to the next question. And then lastly, okay, what should x be for k to be irrational? So you saw that it became irrational when we made x first equal to 1 because 4 minus 1 is 3 and so you have the square root of 3. Okay, so 3 over root 3. So that makes it irrational when x is equal to 1. Okay, and we also know it makes it irrational when x is equal to 2 because 4 minus 2 is 2, so that's still the square root of 2. This is a surd. So when x is equal to 1 or x is equal to 2, and those are our answers. And that is it for question 1. Question 2.1 says, simplify the following. And so we just have to simplify. Okay, so we have 1 term times 2 terms, but then that is squared. So we can work with that squared. So you see, if we have x squared, if we expand this is x times x. So in the same way, we'll just leave that as 2b. Because this is squared, we'll rewrite it twice. So it's b minus 5c times b minus 5c. And then you can distribute. So we have 2b and we multiply. If you distribute, you can't deal with it like this. There's also a quick way to do it, but I'll just deal with it like this. It's fine. And so b times b gives us b squared. B times, and I say I'm missing a c there. Okay, b times negative 5c is negative 5 BC, and then again negative 5 BC in alphabetical order. And then these multiply to become a positive 25C squared. Okay, so before distributing in, just simplify those, okay, to put your like terms together. So we have B squared minus, and that becomes minus 10 BC plus 25C squared. And now we can distribute in. So that multiplies to become 2b to the power of 3. That multiplies to become negative 20b squared c. And then that gives us positive 50bc squared. And that is our answer. Moving on to the next question. The next question, 2.1.2, we have an expression with exponents. Yeah, I know for a fact they definitely didn't mean this. If not, we would not even be able to work with that. So they clearly meant x3 raised to the power of x, okay, not 3x. So I'll just correct that. They probably meant to the power of x. If not, you wouldn't be able to work with that. So this is equal to, do you see how each of these, right? Do you notice there's something in common all through? We have a 3 to the power of x there, okay? 3 to the power of x in that term, 3 to the power of x over here. So how we simplify this is, let's focus on the numerator. And you see that we have two terms in that numerator. But in both terms, we have a 3 to the power of x. So to make this simple for yourself, what you can do is just separate those exponents. So this is 3 to the power of x minus 2 multiplied by. Now, this we can rewrite this as 3 to the power of x. And then how do we get that minus 1? Well, you must have multiplied it by 3 to the power of negative 1. Because if the bases are the same and you're multiplying, then you would add the exponents. So x plus negative 1 is x minus 1. And that's how we got that. Okay, and then all over, we have 3 to the power of x, and we're also separating that, multiplied by 3 to the power of positive 2. And then plus, we have 2 multiplied by 3 to the power of x, multiplied by 3 to the power of 1. And that's how we got that. Okay, so now we still have two terms in the numerator. This term and this term. Remember grade 10, terms are separated by plus or minus signs. Okay, there's a minus sign. So this is one term and that is one term. In both terms, you see that 3 to the power of x is common. Okay, it's here, it's also here. We can take it out as a common factor. So 3 to the power of x comes out. And what are we left with in the first term? Well, what would you multiply to this to get back to that? You'd multiply by 1, okay, because it's just the same. So this times 1 just stays that. And then what would you multiply to this to get back to that? You would multiply by the minus 2, then times 3 to the power of minus 1. We can convert this at this point. So 3 to the power of negative 1. This value, okay, as a fraction, it will have a natural denominator of 1. But its exponent is negative, so to make the exponent positive, you move it from the numerator down to the denominator. Now the 1 is positive. And then we still have a 1 in the numerator. It is not this one here. It's actually the 1 in front of the 3 to the power of negative 1. Okay, they do not switch places. In the same way, 3 to the power of negative 1 over 2 doesn't become 2 over 3. Okay, it's just going to be 1 over 2 times the 3, which is 1 over 6. Okay, now we can just convert that. So that becomes 1 over 3, and then all over, and look at your denominator. Do you see in your denominator, how many terms do you have? You have 2 terms, 1 and 2. And what's common in both terms? It's also the 3 to the power of x. So we're going to take 3 to the power of x out as a common factor, and what are we left with? In the first term, we are left with the 3 to the power of 2. In the second term, we are left with the positive 2, then times 3. Okay, and now we just have to simplify. So these that are common, they would cancel. And now we can cancel. The reason why is because now do you see that you have one term in the numerator and one term in the denominator. Brackets join terms together. And so now it's safe to cancel. So these divide and we are just left with numbers. So let's just simplify the numbers. We have 1 minus, and this is 2 times 1 over 3, which becomes 2 over 3. And then all over that is a 9 plus 2 times 3 is 6. And we're just simplifying. So 1 minus 2 over 3, it's the same thing as saying 3 over 3 minus 2 over 3. It gives you 1 over 3. and then divided by 9 plus 6, which is 15. So you can say divided by 15, or you can just say divided by 15, and then simplify this. So we can use tip and times. So 1 over 3, you're going to tip this, okay? So as a fraction, it is over 1. So you tip it, tip and times works like this. You tip and you times. We're going to swap the numerator and denominator, so it's 1 over 15, and change the division to a multiplication. And then multiply. Numerator times numerator is 1. Denominator times denominator is 45, and that is our answer. 1 over 45. Moving on to the next question. Question 2.2 says, factorize completely. And you can see that we have 4 terms, so we definitely have to use grouping. Okay, so these two, they have a in common, and we could say these two have -1 in common. But the thing about this is, if these were the ones that should be grouped together, then look at what is left if you take out that common factor of a. You would be left with a, and then here, what are we left with? Minus x, okay? Because what you multiply to a to get back to negative ax, that's going to be minus x. Now, a minus x, we know that there will definitely not be a factor of a minus x in here when you take out that common factor of -1, okay? Because there's no a here. So we definitely should not group them like that. Let's see how we should group them so that we have common factors. We could take the a squared with the -1, and then we could take this negative ax with x, because then they would have things in common. And these two, they actually create difference of 2 squares, a squared minus 1. So let's try doing that. So rewrite it as a squared minus 1 and then minus ax plus x. Okay, so this is equal to, and here these two, group them together and then group these two together. So now to factorize this, we can use difference of 2 squares. So open up 2 brackets, and the square root of a squared is a, so that's a times a. Square root of 1 is 1, so 1 times 1, and then plus and minus. And then these. So what do we have in common here? We can take out an x, but it would be better to take out negative x as your common factor. Here's why. If you take negative x out, what are you left with in the first term? If you say negative x times what gives you this, you see that that value is a. See? And that puts the a in front. It specifically keeps a positive a in front. So you can just say x divided by negative x, okay, to find the factor we have here, which is -1. And now do you see that we have something in common? Now, you still need to look at these as the amount of terms that you have. So how many terms do we have in this expression? Here's the minus sign, okay? And brackets join terms together. So these are now 1 term, and that is 1 term. So that would mean that we have a minus 1 in common. So if we take that out as a common factor, then what are we left with in the first term? In the first term, if this comes out, you're left with the a plus 1. So that's a plus 1. And then what do we have left here? We have, if you take that as a common factor, you're left with the minus x. Okay, and there we go. This is our answer, and it has been fully factorized. And that is it for question 2. Question 3.1 says, solve for x, and you can see that we have this equation. Now, it can be tempting to just say divide both sides by x, but you shouldn't do that. And the reason why is because if x is equal to 0, then this is now undefined if you divide by 0. So what we're going to do is take the 2x over, and we have 3x squared, then minus 2x is equal to 0. Okay, now do you see that you have 2 terms, this, and we have a common factor. So we're going to take x out as a common factor, and what are we left with in the first term? So 3x would be left, okay, because you would multiply 3x to get back to 3x squared. And then what you have left in the second term, that will be minus 2 is equal to 0. Okay, so now we have an equation where we have something multiplied by another thing, which gives you 0. The only way this is possible is if the first was equal to 0 and then you said 0 times this, and it gave you 0, or the second was equal to 0 and you said that times 0. So we're going to equate both to 0. So x is either equal to 0 or 3x minus 2 is equal to 0, and then solve for x here. 3x, and we take that 2 over, negative 2 over, and so it becomes a 2. Divide both hand sides by 3, and finally x is equal to 2 over 3. So x is equal to 0, or x is equal to 2 over 3. Moving on to the next question. The next question, 3.1.2, we have an equation and we have fractions. Okay, so with this equation with fractions, let's just see what we have. We have x squared minus 9, which is definitely difference of two squares. And then we have x plus 3, which is one of the factors that we're going to have here. And then we have a 3 minus x. Notice the order. We would have expected it to say x minus 3, and then, it would have something in common with this. But it says 3 minus x. So all that means is there is a negative 1 that is a common factor that we just need to take out. So with this, we have 7 over, and we can just take out that common factor of negative 1 here. And what are we left with? We would be left with, let's start with the x. Would you multiply to this invisible negative 1 to get back to negative x? You'd multiply by a positive x. And then what do you multiply to negative 1 to get back to 3? You'd multiply by negative 3. Okay. And now you can see we have x minus 3. Okay. So this is equal to 5 over, we have x plus 3, and then plus 4 over, and we can factorize this. So open up two brackets. The square root of x squared is x, so it's x times x. Square root of 9 is 3, so that's 3 times 3. And then positive and negative. And this is what we have. Okay, so all through, you see that what we're trying to do is we're really just adding here. And to add fractions, you need to ensure that the denominators are the same. So for example, if you had something like 1 over 3, and let's say 2 over 5. Okay, we can't just add these together by saying, okay, that's 3 and that's 8, because they're not equivalent fractions. They're not fractions that we can compare to each other properly yet. So what we do is ensure that their denominators are the same. So to do that, you see that 3 and 5, to ensure that the denominators are the same, we would have to make both denominators to become 15. Okay, so we're looking at the LCD. So we would multiply this by 5 and 5. You're really just multiplying the fraction by 1 in the form of 5 over 5. Okay, so that's what we're doing there. And then multiply that by 3. So numerator and denominator. And so you see that you would have a 5 over 15 and a 6 over 15. And now you can actually add them together. Okay, so that would be 11 over 15. The denominator stays the same. In the same way, we need to try to make these denominators the same. So this negative, don't let it distract you. It doesn't have to be there. You can actually just bring it to the numerator. So it can be negative 7 over x minus 3. So now looking at this, what should the LCD be? What should their common denominator become? It should clearly become x plus 3, x minus 3, because this one can definitely become that, and that can definitely become that. That one we don't have to change, it's already there. Okay, so now how do you get this fraction to have this denominator? You would do that by multiplying its numerator and denominator by x plus 3. Okay, numerator and denominator. So here we will have negative 7 times x plus 3 over, and now the denominators are the same. So x minus 3 and x plus 3. And we're done with that one. And then is equal to, we have 5 over, now with this one, what do you multiply by? You would have to multiply that to get this to look like this. You must multiply numerator and denominator by x minus 3. So the 5 gets multiplied by x minus 3. And the denominator also, so it becomes x minus 3, x plus 3. Okay, and then that one is already there, so we might as well just leave it. Now, once your denominators are the same, you can drop them, because that was the whole point. We're just trying to make the denominators the same. And really what we're doing is we're taking that LCD, and to get it out of the denominator, you're multiplying both hand sides of this equation by this LCD. So when you multiply here, these would cancel. So that's gone and that's gone. Okay, same thing here. You multiply, it's going to multiply to the first term, the denominators are gone, and then in the second term, the denominators are gone. Okay, so when we do that, all we are left with is minus 7 and then x plus 3. We might as well start distributing. So distribute, it's minus 7x and then minus 21 equals, and distribute, that is 5x minus 15 and then plus 4. And you just have to solve for x here. Okay, so x is on one side, that is negative 7x, and that comes over to become a minus 5x, and they will become minus 12x is equal to, And negative 15 plus 4, 4 minus 15 is minus 11. And the 21 comes over the negative 21 to become a positive 21. And so we will have 10 over here. Then lastly, divide both hand sides of this equation by negative 12 and x is equal to, they both have a common factor of 2. So 10 divided by 2 is 5. Negative 12 divided by 2 is negative 6. And there we go. Negative 5 over 6 is our answer. Moving on to the next question. Question 3.1.3 says we have 16.2 to the power of x minus 1. Yeah, that doesn't seem right. 16.2, if we, try to put that on our calculator, 16.2 is 81 over 5. And 0.5, we know that that is 1 over 2. So they probably meant 16 times 2. And the reason why is because if they actually meant 16.2, seeing that this was also a decimal, they would have put brackets around this. So this is probably 16 multiplied by 2 raised to the power of x minus 1 is equal to, and 0.5 is 1 over 2. Okay, so raised to the power of x minus 4. And this is what we have. How do we solve for x in this exponential equation? So we're trying to solve for x. The way we can do this is, do you see the numbers they're using? 16, 2, okay, a half. They are using numbers that can be written as a base of 2. So how about we just write all of them as bases of 2? So 16 can be written as 2 to the power of 4. And this multiplies to 2 to the power of x minus 1. And then a half. A half is a fraction, and we want this to be written as 2. So we want that 2 to go to the numerator. So it can move from the denominator to the numerator, but what will happen is its exponent, which was a 1, will now become a negative 1. So we will have 2 to the power of negative 1, all raised to the power of x minus 4. Okay, and now let's go. So this is 2 and 2, and they are multiplying, so the bases are the same, and they are multiplying, so you must add the exponents. So this is 2 raised to the power of, and we have x, then the 4 plus the negative 1. 4 plus negative 1 is 4 minus 1, which is positive 3, is equal to. Now here, you have this, which has an exponent, and then it's raised to this exponent. What happens is, using the power rule, your exponents would multiply. So this has one term, it multiplies to the first term, and then the second. So this is 2 raised to the power of negative x, and then positive 4. And now that the bases are the same, we can equate the exponents. So therefore, x plus 3 equals negative x plus 4 and transpose. So we have x, and that comes over to become a plus x, which is 2x. And this is 4, and that comes over to become a minus 3. So it's 1. Then divide both hand sides by 2, and x is equal to 1 over 2. And that is our answer. Moving on to the next question. The next question, we have to solve for this inequality. So we have 2 minus 3x over 4 is less than 14. Okay, so how do we get to the x? How do we solve for x? Well, we need to get rid of the 2 first. Not really this, the 2 first. So that goes over to become a negative 2. So we still have minus, and then 3x over 4, and 14, and becomes a minus 2, so that gives us 12. And now, how do you get closer to the x? Well, we can get rid of this 4, but specifically, let's just get rid of it as negative 4, so we can just get that out of the way. So to get rid of a divided by negative 4, you would multiply by negative 4, but this is an equation, so what you do on one side, you must do on the other side. So here, these cancel, and you have 3x, but here's the thing, you multiply by a negative value. In inequalities, when you multiply or divide by a negative, your signs will change direction. So now it's not going to be less than, it's going to be greater than. So 12 times negative 4, we get negative 48. Okay, and then lastly, divide both hand sides by 3, and we're dividing by a positive number, so it doesn't change. Therefore, x is actually greater than negative 16, and that is our answer. Moving on to the next question. Question 3.2.2 says, write down the first natural number that will satisfy the inequality. So the first natural number. Okay, so the inequality was this. And the solution to this, okay, so the values of x for which 2 minus 3x over 4 is less than 14 was values where x is greater than negative 16. So that is our answer, right? That is the answers that satisfy the inequality, that make the inequality true. And so let's look at what that looks like. This is a negative 16, and we're looking at values that are greater than negative 16. So that would be values that go this way, so the right-hand side of negative 16. And so they want us to tell them the first natural number that would satisfy this inequality. So natural numbers are integer values that are positive, starting from 1, okay, not 0. So we can't take any of these numbers like negative 15, negative 14. We would have to start from 1. So the first natural number that satisfies this inequality, values that are greater than negative 16, would simply be 1. Okay, so this is where x is specifically equal to 1, and that would be our answer. Moving on to the next question. The last question, question 3, says solve simultaneously. And we have two equations and we need to solve for x and y. Okay, so we can call this equation number 1 as equation number 2 and spot the equation that has a variable alone without a number like 2 or 3. Basically, as long as it has a 1 in front of it or negative 1, you can take that. In this equation, we can see that is equation 1. Okay, it has a y. Y is just alone. It's not like 2x where we still have to divide by 2. It's just y. So what we're going to do is take 2x plus y equals 8 and isolate y. So leave y alone and we have 8 and that comes over to become a minus 2x. And now this is equation number 3. And so to solve for x, okay, since this is y as a subject, we would substitute equation number 3 into equation number 2, the equation you didn't use yet. Okay, don't substitute it into equation number 1 because these are really just the same equation, just ordered differently. This one has the 2 on the left. This one has the negative 2 on the right instead. Okay, so we're going to take 2y, and in place of y, we would substitute 8 minus 2x. So 8 minus 2x, and then plus 3x is equal to negative 2. And now we can solve for x. So multiply in, this is 16, multiply in, that's minus 4x, plus 3x is equal to minus 2. And these get added to become negative x is equal to, and we have minus 2 here. When 16 comes over, it becomes minus 16. So this is negative 18. And so you can just divide or multiply both hand sides by negative 1. And finally, x is equal to 18. Okay, so we have solved for x. And how do we get y? Take an equation that had y as a subject that said y is equal to. So that would be equation number 3. Y is equal to 8 minus 2x. But we know x is 18, so substitute it in place of x. And finally, y equals 8 minus 18 times 2 is 36. Okay, so we just get y equals 28, negative 28 specifically. Okay, so these are our answers. X equals 18, while y equals negative 28. And that is it for question 3. Question 4 says, consider the functions, and we have f of x equals ax squared plus c, and g of x equals bx plus q. And they tell us that f and g intersect at points a and b. Calculate the values of a and c. So all we have for a and c in the parabola's equation are 2 points, and these are points of intersection. So how can we use this to find the equation of this parabola? Well, 2 variables are missing, okay, and you have 2 points, so it's enough to find it. And so you're just going to substitute these 2 points individually into the equation of f. So f of x is equal to ax squared plus c, and we're going to take the first point a and substitute it. So this is what we have. In place of x and y, we'll substitute. The y value is negative 3 is equal to a, and then the x value is negative 1, all squared plus c. So let's simplify this. This is minus 3 equals negative 1 squared gives you 1, and so 1 times a is a, plus c. Okay, and you can choose to make something the subject, but at this point I'll just pause and let's just go ahead and find this. Okay, so take the second point and then 2 and 0, and again substitute it in. So this is x and y. The y value 0 is equal to a multiplied by 2 raised to the power of x plus c. So that just becomes a 4 and then multiplies to the a to become a 4a. So you have 4a plus c and then is equal to 0. Do you see how c, okay, in both equations is alone? Okay, here we have a 4a, here we have a. So we can easily make c the subject in both. So c equals, and we can take a over, so it's negative a minus 3. And here, take that over, it's minus 4a equals c. Okay, so since these equations, they both have c as a subject, we can simply say c is equal to c. Okay, so c equals c, and we will just say negative a minus 3 equals minus 4a, and solve for a. Negative 4a comes over to become positive 4a, and then minus a, and then the negative 3 goes over to become positive 3. So that becomes 3a equals 3. Divide both hand sides of the equation by 3, and finally a is equal to 1. Okay, now that we have a, we can find c. Just take the value of a and substitute it in one of the equations for c. So c equals negative 4a, but a is 1. Okay, so c is actually equal to minus 4, and there we go. Okay, so those are our values for a and c. Moving on to the next question. The next question, 4.2, says we need to find the values of b and q. Again, these are points of intersection. So both graphs g and f have these 2 points. The graph of g is a straight line, so we just have to find the gradient, and then we need one other point. So we can actually just use this a and c. So a is negative 1 and minus 3, and then c is just 2 and 0. And so let's go ahead and find the gradient of line AC, or the graph of G. So the gradient, we'll find this by saying y2 minus y1 over x2 minus x1. And so y2, we'll take this as y2. So 0 minus negative 3, and then over 2 minus negative 1. So finally, our gradient is equal to, that becomes a plus. So negative times the negative is a positive. So that becomes a 0 plus 3, which is 3. And then that will also become a plus. So 2 plus 1 is 3. And so 3 over 3 is 1. Our gradient is 1. Now that we know the gradient, we can find c. So this is in the form of g of x equals bx plus q. B, okay, the coefficient of x is your gradient. It's in the form of y equals mx plus c. So you can see that m, the gradient is b, and c, that y-intercept is q. So this is g of x is equal to bx plus q, but we now know that the value of b, okay, which I should conclude here, is 1. So this is equal to 1x, which is just x, plus q. And finally, to find the value of q, you see that if we had something in place of y and x, we would find q. So you just need one point to be substituted. You can take the easier point c, okay? So this is going to go in place of x, and that goes in y. So this is actually 0 equals, and then x is 2, that's q. And now we need to solve for q. So take the 2 over, it's minus 2 equals q, and there we go. So we know that q is simply equal to negative 2. So b equals 1, q equals negative 2, and that is our answer. Moving on to the next question. Question 4.3 says, use the answer sheet provided to sketch the graphs of f and g on the same set of axes. Okay, so our two graphs, remember one is a parabola, the other is a straight line. Now, with the parabola, that's the only one we can actually just focus on and just find certain things about it. Because a straight line just needs 2 points. If you have 1 point and another point, you can draw a straight line and then that's it. But with the parabola, there's special points that you need to find. You need to ensure that you have the turning point and the x-intercept so that you can see what the graph looks like. So let's just work on that parabola. So its equation is going to be a is 1. So it's just going to be x squared and then minus 4. So that's what we have. F of x equals x squared minus 4. And let's go ahead and find that turning point or the y-intercept. So in grade 10, at the grade 10 level, remember that your y-intercept and your turning point are the same point. So if we find the y-intercept, we've found the turning point. How do you find the y-intercept? You find this by making x equal to 0. Okay, because this is the point where x is equal to 0. So in place of x, we substitute 0. So that's 0 all squared minus 4. And so, that just gives you minus 4. Okay, so we can see that the y-intercept as a coordinate, its x value is 0, as we saw. and its y value is -4. And now we can go ahead and find the x-intercept. So we found the y-intercept. Now the x-intercept, we can find this by making y equal to 0. And so we'll just say 0 in place of y is equal to, and we have x squared minus 4. And let's go ahead and factorize that. So 0 equals, open up two brackets, and then that's x times x. And then the square root of 4, that gives us 2. So that's 2 and 2. And we can change that to a plus, and that's a minus. Okay. So that means we have something times another thing gives you 0. It's either that the first is equal to 0, so x plus 2 equals 0, or x minus 2 is equal to 0. Therefore, x is equal to -2 or x is equal to +2. Okay, so these are our x-intercepts. So -2 and 0 and 2 and 0. So we have all the points we need for our parabola now. Okay, let's go ahead and plot. So I'm going to use this paper. We can just go ahead and start with the parabola. The parabola, we have a 0 and -4. So you go 0 and then 4 units down, and that is our turning point. Okay, you don't have to write the coordinates. You can if you want to, but it's not necessary. As long as you show them it passes -4 on the y-axis, they will know it's a y-intercept. And we also have -2 and 2. So it's -2 and 0. So that is -2. And then 2 and 0. And then that's 2. So just join your parabola. It's going to go down like that and then up. Okay, so that is our parabola, and that is f. And then we can draw the graph of g. So the graph of g is a straight line. We already have 2 points. We can just plot those down. So we have -1 and -3. Okay, so that is -1 and -3. So 1 unit to the left, 3 units down. And that point is going to be somewhere here. So that is a point of intersection, meaning, yeah, I should have drawn this parabola a little closer. Okay, close enough. So we can take that. And then we also see that it has another point of intersection, which was 2 and 0. Okay, so 2 and 0. And so just put that down there. So 2 and 0. And then just join your graph. It's going from here to here. So you know that it is a graph with a positive gradient, okay, an increasing function. Okay, so that is the graph of G. And there we go, we've drawn our graphs. Moving on to the next question. Question 4.4 says, determine the value of g of x minus f of x. Well, we can't really find the value because they didn't say at what x value we need to find this. So you can just take g of x and say minus f of x. If it simplifies to something, then there you have that. So let's take the graph of g of x, which we know is g of x equals, and we have 1x, okay? And then that q was a -4. Okay, so we can just take the graph of g, which was x minus 2. Okay, so that is just x minus 2, then minus the graph of f, okay, the equation of f. The equation of f was x squared minus 4. So we'll just say minus, but it has 2 terms. So protect it with brackets, x squared minus 4, and distribute. So this is x minus 2, then distributes in to become minus x squared and plus 4. And finally, the x squared can come first, that is negative x squared, and then positive x, -2 plus 4, or 4 minus 2 is positive 2. This would be g of x minus f of x, if they didn't tell us specifically at what x value they were referring to. Okay, so this is the value of g of x minus f of x. If they said, determine the value of g of x minus f of x at or where x is equal to, and then they give you a value, then you can actually find that. Okay, moving on to the next question. The last question for question 4 says, for which values of x is g of x greater than or equal to f of x? So g of x and f of x, they refer to the y values of their graphs. So if we have this graph, the y values of g, okay, look at the graph of g, the straight line. Look at its y values. They're all through here. So where do we take the y values of g, right? And you notice that they are greater than or equal to f of x. Well, we know where they're equal. They're equal here at their points of intersection. So at which x values are they equal? That would first be at -1. And then the other x value where they're equal is at 2. So at -1 and 2. But now, where is the graph of g? Okay, where does it have y values that are greater than the graph of f's y values? If you look all through here, right? If you use a ruler. So use a ruler. And do you see where the graph of G is? Look at its y value. It's over there. But the graph of F is going to shoot up. So it has a y value somewhere up there. Okay, it has a higher y value there. The graph of G has a lower y value than the graph of F for that particular x value. Okay, so it doesn't work there. But if you keep moving to the right, so you can use a ruler to do this. If you keep moving to the right, look at what happens. At some point they meet. Okay, they intersect at -1, at x equals -1. Then after this, look at what happens. The graph of G now has a higher y value than the graph of F's y value at this particular x value. Okay, the graph of G has a y value over here. So, -2 point something. And then this one is over here, -3 point something. This is greater than that. So this is where the graph of G has higher y values than the graph of F. It's all through here. All through here. And then once they intersect again, we have the same problem. After that, you see how the graph of F now has a higher y value than the graph of G for that particular x value. Okay, so we can see that it's all through in the middle there. Okay, so just highlight that and then line it to the x-axis so that you can tell them the values of x for which this exists. Okay, so we line it to the x-axis. These are all the values. It's values that are, we have to say greater than or equal to -1 because they said g of x needs to be greater than or equal to f. And at this point, this is where they are equal. So we need to take that x value as a valid x value and 2 as well because that's where they intersect. Okay, so you can see that this is where x is greater than or equal to -1. Okay, it goes all through there and then less than or equal to 2. So all of these values in between here, all these numbers in between here, those x values. And so x is greater than or equal to -1, but less than or equal to 2. You can also write it in interval notation as x is an element of, and you're going from -1 to 2. But here we're saying less than or equal to, so use a square bracket and same thing with the 2. And that is our answer. And that is it for question 4. Question 5 says the graph of f, so f of x equals 2 raised to the power of x plus 2 plus k is drawn below. And you can see this is an exponential function. And k, that horizontal asymptote, okay, yeah, they're already showing us what it is. It's passing 1, so you can already see the value of k. The first question says 5.1, use the laws of indices to show that 2 raised to the power of x plus 2 plus k is the same as 4 times 2 raised to the power of x plus k. Okay, the laws of indices, they don't really use this word a lot. It's just exponents, okay? The laws of exponents. So the expression was 2 raised to the power of x plus 2 plus k, and we need to show them that it can be written like that. Now, how do you think they got it to look like that? Well, you see how you just have a 2 raised to the power of x alone? That just means they separated these exponents. And in question 1, you would have seen how we do that. You simply just say 2, okay, and then raised to the power of x, and then ask yourself, what do you multiply to this so that this can look like that? Well, you must have added an exponent to it, meaning it was being multiplied by something with the same base. So it's 2 raised to the power of 2, and then we have plus k, and just simplify. So 2 to the power of 2 is 4, so that's 4 multiplied by 2 to the power of x and plus k, and there we go. Okay, so that is it for that question. Moving on to the next question. Question 5.2 says, determine the value of k. You can already see the value of k. They showed us already. I don't know what they mean by determine because it's not much for determining. You've shown us that it passes 1. But so that we can follow a structured order, because they're giving us 2 marks for this, they can't give you 2 marks for something like that. We can just look at the graph and see that the graph of f has 1 point. It has a y-intercept of 5. So as a coordinate, this point, remember you would have gone, okay, it's just 0 and then 5 units up. So that's 0 and 5. And so that's what we're going to substitute. So take your graph of f, okay, f equals 4 times 2 raised to the power of x plus k, and then substitute that point 0 and 5. Okay, so 0 and 5. And so we know this is x and that's y. So the y value is 5 is equal to 4 multiplied by 2 raised to the power of 0 and plus k. And now k, leave k alone here. 2 raised to the power of 0 is 1. 4 times 1 is 4. And 4 comes over. So 5 minus 4 equals k. Finally, k would just be equal to 1. And there we go. So k is equal to 1. Moving on to the next question. And then the last question, question 5.3, write down the equation of the asymptote of f. Now they're just being really nice, but okay. The equation of the asymptote of f. And the reason I'm saying they're being really nice is because this is a June paper. The whole time when I was looking at this paper, it looked like a March paper, okay? So it looks a lot like a March paper, not a June paper at all, even for grade 10. Okay, so with this, we're just trying to find the horizontal asymptote, the equation of it. You can see it. You can see that it passes 1. It's a horizontal line, okay? A horizontal line passes one particular y value, but it has multiple x values, okay? It has x value here, all through here, x values, okay? All of these x values, it has them, but it has one particular y value, so you can use this to remember it. It is always going to start with y is equal to, and then whatever y value it passes on the y-axis. It passes 1, so its equation is y equals 1. And that is the equation of the horizontal asymptote. And that is it for question 5.3. And that is it for question 5. Okay, so that is the last question for this paper. And I hope to see you guys in paper 2.